Of our last lesson, we said that in the last two lessons, we said that when we have y raised to the power of a, our y forms the base of the number, is the base of the number, while our a is the index of the number, or we call it power of the number. So in our first law of indices, we said that the first law, when we have y raised to the power of a times y raised to the power of b, when the two bases are the same and we have multiplication in between, we say this is the same thing as y raised to the power of a plus b. An example of that, if you have 5 raised to the power of 2 times 5 raised to the power of 3, this is the same thing as 5 raised to the power of 2 plus 3, and that will give us 5 raised to the power of 5. You can see that the two bases are the same. So we have multiplication in between, so we add their indices together. So in the second law, we said that using something similar to this, we have y raised to the power of a divided by y raised to the power of b. Here we have the same bases. The bases are the same, but we have multiplication in between them. In this case, this is the same thing as picking one of the two bases, which is y raised to the power of a minus b. So for example, if you have y raised to the power, if you have 5 raised to the power of 3 divided by 5 raised to the power of 3, we can see that the bases are the same. So and we have multiplication in between them. So what we do is pick one of the two bases, which is 5, and subtract the indices from one another. Subtract these indices from this one. So we have 3 minus 3, and this is going to give us 5 raised to the power of 0. So this is another type of indices. 5 raised to the power of 0 is another type of indices, which leads us to the third law, of indices. Third law of indices. So we are going to have the third law. The third law says that when we have y raised to the power of 0, this is the same thing as 1. Any number, any positive integer raised to the power of 0 is equals to 1. So that is for y not equals to 0. We can't, of course, 0 raised to the power of 0 is not equals to 1. So we can put this, when we have y raised to the power of 0, we can obtain this by using y raised to the power of a divided by y raised to the power of a. Let's call it equation x. That is this one. Let's call it equation x. And if we use a long method, we are trying to prove this law. If we use a long method for this equation x, that is y raised to the power of a divided by y raised to the power of a. This is using the long division method. This is the same thing as y raised to the power of a divided by y raised to the power of a. And this is going to give us 1, since the numerator and the denominator are the same. That is, for example, if you have 5 divided by 5, this is equals to 1. 6 divided by 6 is equals to 1. So y raised to the power of a divided by y raised to the power of a will definitely give us 1. So from here, we can see that and if you are using second law of indices, this is the same thing as y raised to the power of a minus a, because we have division, we have the same basis, but we have division in between them, and this is going to give us y raised to the power of 0, which is equals to 1. Then we go to the fourth law. We quickly go to the fourth law. The fourth law states that, fourth law of indices, it states that x raised to the power of minus a is equals to 1 over x raised to the power of a. From second law of indices, we know that our x raised to the power of a, we can obtain this if we say, for example, we have x raised to the power of 0 divided by x raised to the power of a. This will give us, from our second law of indices, let's call this equation x. Okay, let me use another one. Let's call it equation y. Or let me call it equation n. So using from our second law, from the last law, from the third law, our x raised to the power of 0 is the same thing as 1. It's just like 1 divided by x raised to the power of a, and this is the same thing as 1 divided by x raised to the power of a. So, or from our second law, x raised to the power of a, which is the same thing as x raised to the power of 0 divided by x raised to the power of a, we can prove this using the second law as x raised to the power of 0 minus a. That is from the second law. The bases are the same, so we subtract this index from this, and this is the same thing as 1 over x raised to the power of a. Example, if you have 5 raised to the power of minus 2, this is the same thing as this we can obtain from 5 raised to the power of 0 divided by 5 raised to the power of 2, and this is the same thing as 1 divided by 5 raised to the power of 2, which is the same thing as 1 over 5 raised to the power of 2. Hence, therefore, 5 raised to the power of minus 2 is the same thing as 1 over 5 raised to the power of 2. Let's have one or two more examples on third and the fourth law of indices. 5 raised to the power of 3 divided by 5 raised to the power of 3. This is going to give us 5 raised to the power. This is examples on third and the fourth law. 5 raised to the power of 3 minus 5 raised to, this is going to give us 5 raised to the power of 3 minus 3, because we have division in between, and this is going to give us 5 raised to the power of 0, which is equals to 1. So where we have 5 raised to the power of 3 minus 5 raised to the power of 4, this is going to give us 5 raised to the power of 3 minus 4, and that's going to give us 5 raised to the power of minus 1, which is the same thing as 1 over 5 raised to the power 1, and that's still 1 over 5. X raised to the power of minus n, this will give us 1 over x raised to the power of n if we follow this principle.